before I get to the output, I want to show you something on the spreadsheet, on the data file. See here on this data file, we asked for one is the classification and the distance. Right? Distance from the observation, from each observation, the distance. The other is the classification. So we asked for two clusters, two groupings. See here, now you see this 1, 1, 1, and then 2, 2, 2. Right? So it has classified this into 1, 1, 1 and 2, 2, 2. You might think, well, you know, all this, the ones are given to everything that appears there, right? The numbers above and numbers below get the 2. No, not really. Now we see here, this one is 2, and this is 2, this is 2, and this is 2, and then here are ones again. Right? So it's because the reason for that you get most 2s at the bottom. So you can see that the ones at the bottom are higher numbers. So it does the calculation. So if we go here, just for what we did, we went analyze and classify, and we went to k-means clusters, and then we asked for distance. See here, distance from its classification cluster center. Right? This is the cluster number of the case. Right? So this is the distance of the case. That means observation from its classification center. So the classification center is the centroid that we were talking of. That is the mean value. So this is the distance. So it shows us the distance. Now this is also useful if you want to do various analysis. This is also useful because this shows how distant it is from the mean, the distance from the mean, and this shows the cluster classification. So when you are conducting your research, say you have got some data, and part of this is to find a variable about you have this number of, let's say you have so many variables, and we have only one variable. We'll do another exercise with other more variables. But let's say you have this one variable, and rather than, see here, these are numbers, right? They are passenger numbers. Rather than using like a continuous variable, you want to use this as a categorical variable. That means either into two categories, and you want to look at as two categories: passengers, which airports are busy, and so let's say each of these are representing different airports. Which airports are busy and which are not so busy. There's passengers, and because if you have passengers, let's say these are passengers traveling in airlines, let's say, right? And if you have passengers who are traveling, more passengers traveling in certain carriers, let's say all these are carriers, different carriers, or it could be in the same airline. If you're working for an airline company, maybe these are different routes, from Singapore to Mumbai, Singapore to Dubai, or whatever, right? So different routes, a number of passengers. Because based on this, you can do various other things, right? Like, for example, the catering, what sort of catering that you have to provide, then the in-flight shopping, the discounts that we want to offer for depending on the passenger numbers and so forth. And you can make predictions about using how much revenue you're likely to earn. So this clustering allows you to do that. So rather than using just raw numbers, maybe you decide to categorize, use this as a categorical variable. So clusters allow you to come up with categorical variables. When we come up with modeling or explanations for various outcomes, we want to come up with the best outcomes. That means we want to explain with the most important factors. We don't want to spend too much time on less important factors, because it's not effective way of investing time and resources. So to do that, you have to find factors that are important. Now, to do that, when you build a model, there are so many variables or factors that you want to include in the model. Too many variables or factors that you include in a model to look at outcome, it can be too dense. There's too many to focus on. So one way to get around this is to do cluster analysis. Say you have several variables that you want to group or look at and come up with a single variable. And cluster analysis helps you to do that. So you can come up, this is only one variable that we just looked at. You can have a number of variables, and then they're like the example that I gave you. If you want to open up a supermarket, then you will consider a number of important factors. The customer affordability, how far they are from the supermarket, and any important factors. Now, all those, if the literature says, are important factors that you should consider, or the reports that have looked at such opening of supermarkets or outlets are showing that these are important factors. Then you can collect data and then do a cluster analysis and come up with this kind of clustering. Right? So when you bring all these variables and then do the clustering, it is including all these variables, it's encompassing all these variables, and then making a decision which clusters, to which cluster that these variables should be assigned. And rather than using individual variables, you can represent those variables with one categorical variable like this, cluster analysis, that the output that you get from this. So that's one usefulness of this, the category that you are getting. The second is this distance. This distance also you can use for analysis, because the distance is, well, here's the cluster. Right? Now, with the given cluster, how much distance is there to that given cluster? Shorter the distance, better it is. That means it's closer to the cluster. That means it's more representative of the cluster. Right? So closer distance means it is better. So you can use this information for such analysis. You can operationalize this information as longer distance and shorter distance. and you can operationalize. You can operationalize this as this information that you have got. So these are numerical information again, but you can use that because you have used. Now here we have used only one variable, which is the passenger numbers. But if, let's say, if you had 3 or 5 variables, then it becomes quite confusing for us to relate to each variable. There are 5 variables, and we want to cut down the number of variables because we want to come up with the most efficient model for us to operate or to come up with a solution. But when we want to come up with such solution, then we have this number of variables and then observations. These observations are the ones that are shown here. Right? So let's say this is customer 1, customer 2, customer 3, and so forth. These are the observations. Right? So we ask these customers, or we measure their distance and all that. So we got these different factors related to this customer. And then we can, for that customer, for that given customer, we can, when we are making the decision, we know, well, this customer's importance is less. Right? This customer's importance is more. So we can relate to the cluster in that. So that's another way of using the second column, the third column information here. You will not see negative numbers. You will not, because the distance is from the center. So it is not measuring the distance like, for example, if you are on the west and if you are on the east from the center, say this supermarket is somewhere and there are customers on the west side, the customers on the east side, or customers on the north side and customers on the south side. So when it is measuring the distance, it is not saying, it's not trying to be directional or vector oriented. Right? Mathematical terms you say vectors, right? Or direction. Right? Because direction is not important. If the customer, what is important is the customer is close to the center or not. Sometimes the direction may be important, but in cluster analysis here it's not considering that. It excludes the direction, right? Because here, let's say, let's take a situation like you're trying to open up a shopping center, right? And you are not really worried about whether the customer is living north of the shopping center or south of the shopping center, west or east. You are not worried. All your focus is the customer close by, and will that increase the frequency of the customer visit. So therefore, in cluster analysis, in this instance, we are not looking for the direction. It's the plus and minus open up when we look at the direction, and then we nominate the direction accordingly. But it's not important. You can have 0. Yeah, it's possible. It is possible. For example, if the person is very close to, like for example, in this instance, let's say we have not opened up the center, and this analysis is done to find out where the center should be located or something. Right? And it could be that that the most central point is a place where a customer lives. It's central to all other customers. When we take the whole customer database or the client database, now that might point to a decision for the organization to buy that property, because that's the most central place for customers, right? Because there is 0 distance or closer to 0, because that such a place, such a location would be very convenient for most customers that you have surveyed.